Happy Wednesday! I'm sitting here in the kitchen with some more Mike and Ike candies, and what I want to be able to do is eat a fraction of them. Now, I did that yesterday, but yesterday I literally sorted each of the Mike and Ike candies by hand to equal groups and then selected some of the groups. And that took way too long. I want to be able to do this quickly. I don't have time to be sorting candies all day, especially when I have so much candy. What I'd like to do instead is use a mathematical operation to figure out how many candies I should eat. So if I want to eat 1/3 of the candies, I want to look at the candies and say, okay, there are 70 candies. I want to eat 1/3 of them and know exactly right away what that number is. I don't know how to do that right now, so I'm going to have to learn how to do that first, and then I can apply it to my Mike and Ike situation. I wonder how I can do that. Let's find out.
Before we get on to solving the main problem, I want to talk about yesterday's quiz. A lot of you answered a question in a way that showed a bit of a misunderstanding about what the purpose of grouping is in fractions. You saw a picture like you can see on the screen here, and you saw 3 groups of 3 dots, and 2 of the groups were in the curly bracket, and the question was, what fraction does that represent? And most people answered it with 6/9, or something like that. And the problem with that is that, yes, it's true. This fraction could be represented as 6/9. However, what is the purpose of putting the dots in the groups? The purpose of putting the dots in the groups is so that you can compare the groups to each other instead of the dots. So when you're grouping things, what you're trying to do for the fraction is to compare the groups rather than the dots. And so there are 2 groups selected and 3 groups in total. So the fraction that I was expecting you to write would be 2/3. And now you may be saying, well, why does it make a difference? They're the same fraction. And it's true. 2/3 is the same fraction as 6/9. But again, we're putting the dots into groups for reasons, and I think the reason will become clear when I show you my next example. This question says, shade 2/5 of the boxes. Now, you can't just say there are 5 boxes and I'm going to color in 2 of them, because there aren't 5 boxes. There are more than 5 boxes. So what we have to do first is to group them and then shade the groups, not the individual boxes. So I see 10 boxes here, so I'm going to have to group them so that I have 5 groups instead of thinking about 5 boxes. So let's do some grouping. 1, 2, 3, 4, 5. Now I have 5 groups. And how many should I be shading in? Look at the numerator. The numerator says 2. So I should shade in 1, 2 of the groups. So let's do it. 1, 2. And the rest of them should be white. That's how you shade in 2/5 of the boxes. I don't have 5 boxes with 2 of them colored in. I have 5 groups of boxes with 2 of them colored in. Another example. This one says shade 2/3 of the boxes. And I can't just say there are 3 boxes and 2 of them are colored in, because there are more than 3 boxes. So I have to look at the number of groups. How can I put this into 3 groups? Well, it would look something like this. 1 group, 2 groups, 3 groups. The denominator says 3, so I've broken it into 3 groups. How many groups am I going to shade? Well, the numerator says 2, so 1, 2, 2 out of 3. So let's shade 2 out of the 3 groups. 1, 2. And the last one stays white. I have 2/3 of the boxes shaded, even though I have more than 3 boxes to color in. One more example. This one says shade 3/4 of the boxes. So I have to break it up into groups of 4. That's a little bit difficult because there are 12 of them, but I think I can do it. And it would look something like this. 1 group, 2 groups, 3 groups, 4 groups. And how many should I shade in? The numerator says 3. 3 out of the 4 groups. So I'll shade in 1, 2, 3. And the last one stays white. Again, I haven't said there are 4 boxes and 3 of them are shaded in. I'm saying I've shaded in 3/4 of the groups. Now it's your turn. Now I know you can't color the screen, so you're going to have to either color them in your mind or copy them onto a piece of paper and color them in on the piece of paper. Remember, you need to group the boxes first before you color them in. Press pause to try it, then press play to check your answers. Welcome back, let's check your answers. In the top left corner, we have 2/3. 2/3. And so we have to group those boxes into groups of 3 and color in 2 of those groups, and it would look something like that. 1 group, 2 groups. Let's look at the question in the top right. It says color in 1/2 of the boxes. 1/2. So there are 2 groups, and 1 of the groups is colored in. Look at the problem in the bottom left. It says color in 1/4. That means there are 4 groups, and 1 of the groups is colored in. So 1, 2, 3, 4, but only this one is colored in. And finally, 5/8. That one's tricky. You need to divide it into groups of 8 and then color in 5 of those groups. The groups are going to be like 1, 2, 3, 4, 5, 6, 7, 8, and then we'll color in 5 of those groups to look something like that. Now that we've reminded ourselves that we're focusing on groups rather than individual pieces, we can move on to the main problem here. Now last time you had to solve a problem like this. What is 1/4 of 12? And what we did is we made 4 groups, because the denominator says 4, and then we split up the Mike and Ikes evenly, because fractions always have evenly divided amounts. And so we went 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. And we just had to choose one of those groups, and there were 3 in that group. 1, 2, 3. And so we said that 1/4 of 12 is 3. But what if we could do that without having to actually sort bits and pieces? What operation are we doing? Is there a division statement that represents what we just did here? I think there is. Look what we did. We had 12 candies, and we divided them into 4 equal groups. 12 divided by 4. So what I'm saying is that 12 divided by 4 equals 3 means the same thing as 1/4 of 12 equals 3. What's the pattern? The pattern is you're dividing by the denominator. So now I'm going to give you some fraction problems, and I want you to turn them into division problems, remembering that you have to divide by the denominator. So rewrite these fractions as division statements, and then solve them. Press pause to try it out. Press play to check your answers. Okay, let's check your answers. Starting in the top left, it says 1/6 of 12. So the denominator is what's telling us to divide. We divide by the denominator, so that's 12 divided by the denominator, which is 12 divided by 6. And we could divide 12 by 6 easily because we know that 6 times 2 is 12, so 12 divided by 6 is 2. Next question in the top right. 1/5 of 15. Our denominator is what tells us to divide, so what we're trying to find is 15 divided by 5. But what's the answer? Well, we know that 5 times 3 is 15, so 15 divided by 5 is 3, which means that 1/5 of 15 is 3. 1/4 of 20 in the bottom left. First, we convert it to a division problem. The denominator is 4, so it's 20 divided by 4. What is 20 divided by 4? Well, we know that 4 times 5 is 20, so 20 divided by 4 is 5, which means that 1/4 of 20 is 5. What about 1/2 of 16? Well, we know the denominator is what you divide by, so 16 divided by 2. We know that 2 times 8 is 16, so 16 divided by 2 is 8, which means that 1/2 of 16 is 8. Well, that's much faster than having to move all of those candies into groups that you make yourself. It can save you a lot of time to just use your division facts. But all of the examples that I've given you so far had a numerator of 1. What if you have a different numerator? What if you have a numerator of 2, for example? Well, last time we saw the question, what is 2/5 of 15? And the first thing we did is look at the denominator and say, oh, there are 5 equal groups. And then we started sorting those candies into those 5 equal groups. That was our division part. And then after we finished sorting the candies into those 5 equal groups, we asked ourselves, how many is in one group? And the answer was 3. But then we said, we're not done yet. Because the numerator says we need to have 2 of those 5 groups. So we had to look at 2 of those 5 groups, and then skip count to get our final amount, 3, 6. So first we did division, and then we skip counted within the groups. And skip counting is just another way of multiplying. So how do you use mathematical operations to find the fraction of a whole number? First, you divide by the denominator, then you multiply by the numerator. Because what we're saying is 2/5 of 15 equals 6 is the same as 15 divided by 5 times 2 equals 6. The key is divide by the denominator, multiply by the numerator. Divide by the denominator, multiply by the numerator. Are you ready to do it yourself? I'm giving you 4 of these fractions, and I want you to rewrite them as division and multiplication statements, and then solve them to find out the answer. Remember, divide by the denominator, multiply by the numerator. Give it a go, then press play again to check your answers. Okay, let's see if you can do this. Top left corner, 2/5 of 10. So we're going to have 10, and then divide by the denominator of 5, and multiply by the numerator of 2. 10 divided by 5 times 2. Well, what is 10 divided by 5? 10 divided by 5 is 2. And then we have to multiply that by 2. And 2 times 2 is 4. So 2/5 of 10 is 4. Let's look in the top right-hand corner here. 5/6 of 18. So 18 divided by the denominator of 6, multiplied by the numerator of 5. Well, 18 divided by 6 is 3, and then multiply that by 5. 3 times 5 is 15. So the answer is 15. 5/6 of 18 is 15. Question in the bottom left. 2/3 of 21. Divide 21 by the denominator of 3, multiply it by the numerator of 2. 21 divided by 3 is 7, and then 7 times 2 is 14. So 2/3 of 21 is 14. And then finally, in the bottom right-hand corner, 3/8 of 16. Divide 16 by the denominator of 8, multiply it by the numerator of 3. 16 divided by 8 is 2, and then 2 times 3 is 6. So 3/8 of 16 is 6. And using those 2 easy steps, you can find the fraction of a number without having to count out all those pieces.
I have 60 Mike and Ikes on the table here, and I want to eat 2/6 of them. So what do? I don't want to count them out, that takes too much time. Instead, I'm going to divide and multiply. Divide by the denominator, multiply by the numerator. So 60 divided by the denominator of 6, multiplied by the numerator of 2. 60 divided by 6 times 2. Well, 60 divided by 6 is 10, times 2 is 20. So I can eat 20 of the Mike and Ikes. I'm going to get started now. I think I'm going to start by eating a green Mike and Ike candy to match my shirt. And while I'm doing that, I want you to complete pages 215 and 216 in your Jump Math book, and then complete the quiz that pops up later. Enjoy your math. I'm going to enjoy my candies. Happy Wednesday!